Okay, so our in the function, in the setup, we have x minus h. So when I put in that h is -3, what I'm saying is this, right? Which then gives you x plus 3. Okay, so when you see the brackets, when you see the transformation in this form, and I ask you what is h, pay attention to the sign. It's going to be the opposite sign that you see, because we always start with a minus, and if it's a negative, then it's minus and minus, and that's what makes it positive. So just be careful of that notation there. And lastly, because we have 4 here, K represents a vertical translation, positive units up, negative units down. And again, this is just an overview of what we already did in Unit 1. So on our next page, we're going to do an example. I'm hoping these are easy examples because we just wrote the test on this. Here are my 3 components. I have an K, I think I did in yellow. What did I do in blue? I think was the B, there, and there. There are my 4 components. And how will I identify them? So again, I'm more interested in making sure that the sign is correct and that the way that you write it is correct when we are describing things. So parameter A is -2. So the 2 is telling me I have a vertical expansion by a factor of 2. And because it is negative, I'm having a reflection over the x-axis. So it's being expanded and reflected. Looking at the B value, I see a B value of 4. This tells me that I have a horizontal compression by a factor of 1/4. Right? Compression because it's a number greater than 1, but when I represent it in terms of my mapping, and by the factor is going to be 1/4. Parameter H is in yellow. Parameter H, oh sorry, no, the parameter H is in purple. So I see a -3 here, so this is a +3. This means I'm being translated to the right 3 units. And then for parameter K is a +1, so I'm going up 1 unit. When we do the transformation, it says here, create a table of values and describe the transformations that are going on. The way that I do this in the most simplest and efficient form is by writing out the mapping. My original coordinates x, y, what is going to happen to them after I do these reflections? So looking at the x components first, where are my x's? The B value is an x and the H value is an x. I know that I'm getting compressed by 4, so x divided by 4, and moving to the right 3, so I'm adding 3. Then I look at the vertical components, A and K. I'm getting flipped and expanded by -2, so -2 times y, up 1. Okay, because I've already described and identified my transformations. In order to create a table of values quickly and effectively, I need to know what to do with each of those numbers. Now, the key points that we looked at in the first page, 1, 1, 0, 0. You could do it in table of values form, but I find coordinate form a little bit more effective. 1, 1, 4, 2, 9, 3. What are they going to get mapped to? So all of the x's are getting put through this filter, and all of the y's get put through this filter. Zeros are very easy because they are unaffected by stretches and they're unaffected by reflections, because you can't multiply or divide anything with 0 and get a different number. It's going to be 0. So zeros are only affected by translations. So in my x coordinate, this is going to be 3. My y coordinate will be 1. When I go here, you're going to get some ugly numbers sometimes because of our fraction here. Technically, this is 1/4 plus 3. This is going to be ugly. Could you do it? Sure. I don't want to. I don't need to graph all my points, right? I want to just graph some key points in order to make my graph look like it should in the transformation. So this one will be ugly. I can do it, but then I don't know how to graph a fraction because my scale doesn't allow for that. So I'm going to choose in the next one. 4 is easily divided by 4. 4 over 4 is 1. 1 plus 3 is 4. 2 times -2 is -4, plus 1 is -3. I go to my next one, 9. 9 over 4, also ugly. I'm not going to do it. Can I get away with just 2 points? Sure. Let's give it a go. I have 2 points that I know for sure. 0, 0 gets mapped to 3, 1, right there. And 4, 2 gets mapped to 4, -3, right there. Now, for this particular one, there's 2 methods to figure out which direction this should be, because in theory, I could have it go like that, right? It could curve that way. It's always going to be some kind of a curve because it's a radical, or it could be curving this way. So 2 options, either find a third point or reason through some of your transformations here. I know that I flipped it upside down and I made it taller, and then I moved it to the right, and then I moved it up. So I know it's going to have this kind of shape. If your brain hurts while thinking about that, no problem. Let's find another point. What's easily divisible by 4 and I can square root it? 16. So 16 square rooted gives me 4. And when I map it, 16 over 4 is 4. 4 plus 3 is 7. 4 times -2 is -8, plus 1 is -7. So here's my third point. 7, -7. Oops. There we go, somewhere here. So with the third point, now I can see the curve. Here is my transformed graph. Always make sure that you are drawing an arrow for any graph that goes off to infinity. You don't want to be connecting dots only. A, because it's wrong, because this is telling me that I can only be between those 3 points. And then I don't know which way it should extend to. Right? We want to make sure that we are drawing accurate representations of our transformations. It's starting at this point and going down and to the left forever. Now, let's talk about domain and range. In my original, I could only have positive x's, and the result only gave me positive y's. So my original domain and range, oh, it's already written down here. My original domain and range was positive numbers. With my transformed domain and range, if you have a picture, hopefully you can just look at the picture and tell me. Can I have a brave soul tell me? What is the domain and range for the pink graph? Will x be greater than or less than a number? It's going to be greater than because it's moving to the right. And what's the number? What's my starting point? 3. Okay, what about y? Greater than or less than? Less than. And my starting point? 1. Okay, so if you have a picture, you can easily find the domain and range by just observation. You can also do this mathematically. So mathematically, To find the domain, anything in the square root has to be greater than or equal to 0. So I'm going to take what's inside of my radical, 4 bracket x minus 3. 4 bracket x minus 3 has to be greater than or equal to 0. And I solve for x. I divide by 4, gives me x minus 3 has to be greater than 0. And then I add 3. So x has to be greater than or equal to 3. That is what I originally started with. All right, one moment, please.